The reality that a console launched in 2006 managed to host the most ambitious entertainment product of its era is fundamentally absurd. To understand the scale of this achievement, you have to look past the graphics and into the silicon. While modern gaming PCs boast 32GB of high-speed memory, the PlayStation 3 was operating with a grand total of 512 megabytes. That is less memory than a single tab of a modern web browser requires to display a basic page. Yet, Rockstar Games forced this aging machine to render a 75 square kilometer world filled with hyper-realistic physics, dynamic lighting, and a functioning ecosystem. This wasn't a matter of brute force power. It was a masterful display of software illusion and engineering desperation. The primary antagonist of this project was the PlayStation 3's notorious architecture. The system was powered by the Cell processor, a beast of parallel mathematics that was famously painful for developers to code for. While some major studios saw their games collapse into unplayable slideshows or corrupted save files on this hardware, Rockstar chose to attack the machine's limits directly. The most significant hurdle was the memory split. Unlike modern systems that use a unified pool of RAM, the PS3 divided its 512 megabytes into two distinct 256 megabyte cages, one for the system and one for video textures. This meant that if the game needed more high-resolution data for the asphalt of Los Santos, it couldn't simply borrow space from the system side. It was a technical prison that forced the developers to rethink the very nature of how a world is loaded. To bypass these physical constraints, Rockstar implemented what is perhaps the most brilliant disguised loading screen in gaming history, the character switch. When you transition from Michael in the city to Trevor in the desert, the camera zooms into the sky, pans across the map, and drops back down to a new character. While you are watching this seamless cinematic transition, the console is actually having a technical panic attack. It is frantically dumping gigabytes of city data from the RAM and fetching desert assets from the disk before the camera hits the ground. This wasn't just a cool narrative mechanic, it was a resource management trick that allowed the game to exist in a world where the hardware could only hold one neighborhood at a time. However, the memory wasn't the only bottleneck. The physical speed of the disk drive was a looming disaster. The PS3's Blu-ray drive could only read data at about 9 megabytes per second, which is far too slow to keep up with a player driving a supercar through a dense urban environment. If Rockstar had relied on the disc alone, you would have frequently driven into a void of untextured buildings and invisible roads. Their solution was the dual streaming system. By forcing a mandatory 8GB installation, the game could pool high-resolution textures from the hard drive while simultaneously streaming audio and physics data from the physical disk. Two separate pipes of data were fed into the processor at the exact same time, just to keep the simulation from collapsing under its own weight. To maintain the frame rate, the engine also relied on aggressive visual sacrifices that the player was never meant to see. Level of detail scaling. Every vehicle and building was swapped for a low-poly cardboard box version the moment it moved a certain distance from the camera. Traffic culling. The highways of the PS3 version were significantly emptier than later releases to save the CPU from calculating complex AI logic. Occlusion culling. The engine would completely erase any object, even a skyscraper, the moment it left the player's field of view. Euphoria physics. Character animations were simulated in real time to save memory on pre-baked animation files, making every fall and collision unique, but computationally expensive. These tricks were a necessity because the PS3 was a locked box with a fixed ceiling. Unlike modern PC development, where studios often lean on AI upscaling and frame generation to cover for unoptimized code, the developers of the 2000s had no safety net. Every byte of memory had to be accounted for, and every cycle of the processor had to be hand-tuned. Optimization in this era wasn't a post-launch patch, it was a craft that began on day one. This discipline is what allowed GTA 5 to look and run better than games that arrived years later on the same hardware. It was a testament to the idea that hard limits often force the most profound ingenuity. When we look back at the PlayStation 3 era, we aren't just looking at old hardware, we are looking at the peak of manual optimization. Today, we live in an age where we use artificial intelligence to hallucinate pixels because we've forgotten how to build for the smallest box. Rockstar's work on the PS3 remains a reminder that software isn't just code, it's an art of managing limitations. They didn't just make a game run on a 2006 console, they tricked that console into believing it was more powerful than it actually was. In the end, the most impressive part of Los Santos wasn't the map size or the story, but the invisible workers behind the scenes constantly deleting and rebuilding reality just to keep the illusion alive. As we move toward a future of infinite hardware power and AI-driven performance, we should remember the lessons of the past. The impossible worlds of yesterday weren't built with more power, they were built with more care. True innovation doesn't come from having no limits, but from finding the most creative ways to break through the ones we have. That was the real magic of the PS3 era, a time when the hardware said no, and the developers found a way to say, "Watch me."